All right, you guys, today we are on section 4.8, some applications and models. We're going to actually be reading some word problems and having to draw our own right triangles and then be solving, of course, for an indicated side or angle, etc. Now, definitely need your calculators, of course, for this, so please make sure you have that handy. I'm going to punch a few things in, of course, to show you, just to remind you. Make sure everything, your mode is in degrees, everything is in degrees today, no radians needed. All right, solve the right triangle shown in the figure, rounded 2 decimal places. Clearly, we need to draw the figure. You will have a picture of a right triangle. The right angle is always C, and then the acute angles are A and B. Now, the side opposite angle A, side A, which they tell us is 25. The opposite side of angle B, side B, which they give us is 37. Now, solve the triangle means we want to know all 3 angles, all 3 sides. So, first, probably the easiest, you know 2 sides of the right triangle. Let's find the 3rd side, the hypotenuse. I'm just going to use some old school Pythagorean theorem. A squared plus B squared equals your hypotenuse squared. And then, of course, we're just going to go through and solve this. I know you can do Pythagorean theorem. I'm not going to bore you with it. You get about 44.65. Round to 2 decimal places, hence why I did that. Now, other thing we need, of course, angles. Doesn't matter which angle we find first, A or B. I'm just going to keep it easy and go alphabetical order. I'm going to do angle A first. Now, we know all 3 sides of the triangle, so I'm going to decide which trig ratio to do. This is just a little pro tip. I usually use the given sides just in case if I would have messed up side C, the hypotenuse, now that could potentially affect my angle A if I use it and it's wrong. So I'm going to use the given side. So across from angle A, we've got our opposite side, and then we have our side next to it, the adjacent side. So do tan, opposite over adjacent. Again, you technically could have used any of the trig ratios since you know all 3 sides, but I try not to use the side I found in case there was an error in that I don't want it to also affect my angle. Now, double check your mode, of course, in degree. Once you have that selected, just quit out of that. And now, to figure out the angle measurement, we're not just going to hit tan, we have to hit second tan. Second tan gives you the degrees, the angles. And we have 25 divided by 37. Now, it doesn't matter if you close up the parenthesis or not, you will get the correct answer. It says round to 2 decimal places, so I'm going to put that as 34.05 degrees. All right, so the last thing we have to do, of course, is B. Now, you could do another trig ratio. Again, you have all the sides. You could do sine, cos, or tan. Or, easiest way, all 3 angles in a triangle should add to 180. We'll throw back to geometry. So I'm just going to take off the given right angle. You can do that in your head. And then I'm going to subtract off our angle A. And you can do that all in your calculator. You're going to end up with 55.95 degrees. So nothing new. Just when it says solve the triangle, you want all 3 angles, all 3 sides. All right, let's do another one because here they're going to use some degrees and minutes. So just a little quick review, of course, where to find that in your calculators. And see. Okay, so the side across from angle A, still, of course, side A. I'm going to go ahead and label that. Angle B this time they give me, I'm going to fill that in, 65 degrees, 12 minutes. Okay, so first we know 2 of the 3 angles. I would probably find the missing angle. So I'm going to start with finding angle A. Now, all 3 angles, of course, in a triangle add to 180, so I'm just going to take off the right angle. Again, you can do that in your head, and then I'm going to subtract the 65 degrees, 12 minutes. Now, this I am going to punch in the calculator for you just because it's been a little bit since we've done degrees, minutes, second. Clearly, I'm not typing in 180 minus 90. I'm going to do that part in my head. So I'm going to have 90 minus 65 degrees. So you have to get in your angle menu. So remember that is second apps. There's our degree symbol, and then 12 minutes. Again, in the angle menu, second apps, minutes, of course, number 2, and then hit enter. So it gave me 24.8. That's the degrees. Since the given angles in degrees minutes, I want this degrees minutes. So then I'm going to get back into my angle menu and hit number 4, convert to degree minute second. So I'm going to put, I'm not going to put the 0 seconds. I'm going to put 24 degrees, 48 seconds for it. All right, and just another quick review on your calculator just to show you on seconds. For whatever reason, I don't know why they can't put them all in the same menu. Remember, seconds, you have to hit that alpha. let's pull it up here. I'm losing the calculator. You have to hit the alpha plus, right above enter. You can see the plus key and then the little seconds. Okay, still got to get some sides. So we need, of course, side, and we need, of course, our hypotenuse, side C. I always work off the given information, just like the last problem, just in case we might have messed anything up. So I'm going to work off my given angle B. First side I'm going to find is the one across from it. So I need the opposite side and they gave adjacent. So adjacent, I'm going to do tan. So this time we know the angle, 65 degrees, 12 minutes, equals opposite over adjacent. Now I'm just going to use some algebra skills to get B by itself. I'm going to multiply each side by 145.5. Okay, to the calculator we go, my friends. So I'm going to pull up the calculator, 145.5. Up to you if you put the times in or not. It will clearly know to do that. I'm just going to go ahead and hit tan, and then I'm going to put in my angle, 65 degrees. So back into that angle menu, second apps, and then of course 12 minutes, second apps again, and select number 2. I'm going to close it up. You don't have to. It will take it. It won't mess it up. And I'm going to round that to 2 decimal places, so 314.89. So let's list that. Okay, now you have 2 of the 3 sides of your right triangle, so you could do Pythagorean theorem again. Personally, with the decimals and these large numbers, I think Pythagorean theorem might be a little obnoxious. So this time I'm still going to do a trig ratio. So I've still got my adjacent to the angle, and I need hypotenuse. So adjacent hypotenuse, this time maybe cosine. Cosine of our angle, 65 degrees, 12 minutes, equals adjacent over hypotenuse. Again, I'm going to use some algebra skills. I would just multiply each side by c to clear out the denominator. And then to get c by itself, we're going to have to divide off cosine, 65 degrees, 12 minutes to each side. And of course, we're just going to type that in the old calculator, and we're going to end up with about 346.88. And again, you could have used your Pythagorean theorem. You'll get the same answer. You just have kind of some large numbers, but it's however you want to do it. Doesn't matter to me. All right, next up, some word problems. Actually, I think these are easier because there's less to find. We just have to draw our own picture. Clearly, we're in the right triangle chapter, so I'm guessing these will be right triangles. An electrician's running a wire from the electric box in a house to a utility pole 75 feet away. The angle of elevation to the connection on the pole is 16 degrees. How much wire does the electrician need? Okay, angle of elevation is the angle made from your line of sight, of course, and looking up. So here's your little electrician. I know, my artistic skills are really awesome. He's running wire from the electric box in the house to a pole 75 feet away. So here's my pole, and I know it's 75 feet away. Clearly you can see my right angle happening. And it says the angle of elevation is 16 degrees. So from his line of sight looking to the top of the pole. Question is, how much wire does he need? Now remember, he's running the wire from where he's standing to the top of the pole. So this is the side we need to find, the hypotenuse. So from our angle, I'm going to label our sides. We have the adjacent side, and we need the hypotenuse. Adjacent hypotenuse, we're going to do cosine. So cosine is 16 degrees equals adjacent over hypotenuse. Now I'm just going to use my algebra. I'm going to clear out that denominator, times each side by x. And then, of course, to get x by itself, we're going to have to divide by cosine of 16 degrees. So in your calculator, you're just going to type in 75 divided by cos of 16. It doesn't say what to round to, so I just rounded it to the whole unit on this one. And I'm going to put a label on it, though, here in feet. So not too shabby of a problem. You just have to remember angle of elevation is from the line of sight to the top. All right, next up, the front of an A-frame cottage has the shape of an isosceles triangle. Yes, geometry. Isosceles, 2 congruent sides. So I'm going to draw my isosceles triangle. There's the A-frame. Okay, mark those congruent. It stands 28 feet high. Now, the height, of course, always goes right down the middle of the triangle and makes a right angle. And we know it's 28. All right. Angle of elevation of its roof is 70 degrees. Now, from either corner looking up, 70 degrees. These are both going to be 70 degrees. Hey, little geometry throwback, base angle theorem. Two sides are congruent of an isosceles triangle. The base angles are congruent. I couldn't help myself there. What is the width of the cottage at the base? So they want to know this entire bottom green piece of the triangle. Well, clearly we have two right triangles in this picture. I'm just going to draw out so I can mark on it the left side of it. So we've got the 70, the right angle, we know this is 28, and we're working on the bottom piece, the base. So of course across from 70 we have our opposite side, and we are trying to find adjacent. So opposite adjacent, clearly I'm going to do tan. So tan is 70 degrees equals our opposite over adjacent. Now, same principles as the past problems, we want to multiply by our denominator to clear out the fraction. Most of you can just do it in your calculator from here. We're going to have to divide off tan of 70. Okay, and of course, type that in your calculator. You are going to end up with about 10.19. Now, not our final answer, not our final answer. That is only the left half of the triangle. Clearly, the triangles, if I could draw, would be congruent since it's isosceles. So the right side is also 10.19. So of course, we're going to add those together for a final 28. I'm going to put a label on it. Feet. Okay, a little throwback to geometry. I was glad we got to do that problem. All right, example number 4, airplane ascent. Oh, you're going to love my drawing of an airplane. When an airplane leaves the runway, its angle of climb is 18 degrees and its speed is 275 feet per second. Find the altitude, height of the plane after a minute. Okay, so let's start with drawing our runway. There it is. I know, it's pretty impressive, my drawing skills. An airplane leaves the runway, its angle of climb is 18 degrees. So my airplane, of course, it's off the ground, it's up the air, it's moving. Here's my airplane up in the sky. I know, that's very nice. 18 degrees it's climbing. Here's our right angle. So we can see our right triangle coming together here. Now, we got to get creative because they tell us, of course, the 18 degrees I have labeled. It also gives me how fast, the speed of it, and how long it's in the air. I would like to know the distance. What did it cover? How many feet is your airplane actually off the ground? So I'm going to have to go old school and use some rate times time to get the distance. So our rate, of course, 275 feet per second. Our time is a minute. Well, we got to do a little unit conversion. Seconds, minutes. There's 60 seconds in 1 minute. So I'm going to multiply that out clearly in my calculator. And I know that's plane. So from our starting point down here in the corner, the plane is now 16,500 feet for a distance. Now, we want to find the altitude, the height of the triangle, the right angle, so we want this right here. So my 18-degree angle, the opposite side, and we know the hypotenuse. So opposite hypotenuse, I'm going to use sine. Sine 18 degrees equals my opposite over my hypotenuse. And just a little algebra skills here to get this solved. We're going to multiply each side by the denominator. And of course, type that in the calculator. So I just rounded it to the whole unit this time since the 16,500 is a whole unit. So I'm going to put 5,099 feet. And again, if it doesn't specify what to round to, I'm not going to be very picky about that. I usually, since I see like the numbers in the given problem are all whole numbers, I round to the whole. I try to kind of follow the problem if I can. All right, couple more pictures for us. Yes, I did cheat. I got this one off of clip art to help my drawing skills a little bit. So from a point 50 feet in front of a church, there's the picture of the church, the angles of elevation to the base of the steeple. Now for those of you, the steeple of course is the cross here at the top. The base of the steeple and the top of the steeple, 35 degrees, 47, let me reread that. 35 degrees and 47 degrees, 40 minutes respectively. Find the height of the steeple. Okay, so let's start from 50 feet in front of the church. So let's estimate, here's our point. This covers 50 feet. Next up, angle of elevation to the base of the steeple. So I'm going to draw that in next, to the base of the steeple. Okay, and then to the top of the steeple. Now, the first angle, of course, it says is 35 degrees. So that's the smaller angle. And then the other one made with the blue line, I'm just going to kind of dot it across here, that whole thing, 47 degrees, 40 minutes. Clearly, that one is larger, hence why it's the bigger value. They want us to find the height of the steeple. So I just need that part. And of course, we've got our right triangle here. Got it. All right, so I'm going to take a look at our angles, our green 35 and our blue 47 degree one. We've got our adjacent side here. And clearly, we're working on the opposite side. Now, let's first find the opposite side, just the height of the church. I'm going to use a different variable. I'm going to call that x. We need the opposite. So I'm going to use my 35. I need opposite of 35, and we know adjacent 50. So I'm going to do tan, because we have multiple right triangles in this picture. Opposite, adjacent. Just like all the other problems, I'm going to multiply each side by 50. And I typed that in the old calculator, and you end up with about 35 feet. Every value in the problem was a whole number, so I just went with a whole number. So I'm going to go ahead and label that on my picture. Okay, now we want the height of the steeple, just that little top H part. So I'm going to do tangent again, but that is on the overall large right triangle. So I need the blue angle, the 47 degrees, 40 minutes. Now, the opposite side is the height of the steeple, which we're trying to find, and the height of the church, which we just found, the 35 combined. So I'm going to have to do a little adding of those two pieces to get that entire side of the triangle, the adjacent still 50. All right, there's a setup now in algebra. We're going to multiply, of course, each side by 50 to clear out the denominator. And then you would have to subtract the 35 off, just to be left with the height of the steeple. All right, and I literally just typed that in my calculator just as it appeared. I didn't do anything fancy with it. You end up with 20 feet. So this is probably one of the tricky problems because you do have multiple right triangles in the picture. Careful on that one. All right, last one. An airplane flying at 550 miles per hour has a bearing of north, I should say bearing, not bear, bearing of north 52 degrees east. So before I read any further, I'm right away thinking about the compass rose, north, south, west, east. So I'm going to draw out my compass rose coordinate plane. North, south, west, east. Okay, let's carry on here. So airplane flying. Now we always start, anything we graph, we always start, of course, at the origin. It is flying north 52 degrees east. So northeast would put you out here in quadrant 1. So here's my little airplane. Yes, I know my drawing skills just keep getting better. After flying 1.5 hours, how far north, how far east has the plane traveled? Well, first let's get this angle, the 52 degrees labeled. So from the origin, he went north, east. So this, of course, is my 52 degrees. And here's a little pro tip. Your bearing angle is always made with the vertical, the north-south line. It always just works out that way. And we want to know how far north, so I need this side, and how far east. So we need the two sides of the right triangle. Now, they do give us some other information here that's going to be useful. We can find the hypotenuse of this triangle, or how far out the plane is. We're going to have to use that distance equals rate times time again. So the plane is flying 555 miles per hour, and it's been out there 1.5 hours. So I just multiplied that out in my calculator, 825 miles. So there's my hypotenuse. That's how I got that. Okay, now I'm ready to go. Let's find, I'm going to do x first, how far north. So according to my 52, of course, that's the adjacent side, and we know the hypotenuse. So I'm going to do cosine 52 degrees equals the adjacent side over the hypotenuse. You would multiply by 825. We can all do that. Punch it in your calculator. You end up with 508. And I'm going to label that 508 north. Just to make it look nice. Now, choices on finding, of course, the third side. You Pythagorean theorem, totally fine. We could do another trig ratio. Just for fun, I'm going to do another trig ratio. Now I need the opposite side of 52. And of course, I would work off the given hypotenuse in case you made an error on the 508. You don't want it to affect this. So let's do opposite hypotenuse. So now I'm going to do sine 52, opposite hypotenuse. And of course, you just multiply each side by 825 and type that in your calculator, and you end up with 650. And that is how far east we went. Okay. A little bit of bearings. And again, I just rounded everything to the whole number on this one. I'm not going to be picky about the rounding. All right. Hopefully you guys have better drawing skills than I do. Have a great day.